Okay, so everyone's into building the Easy Spin motor by Laser Saber. Lid Motor's done some wonderful variations on the motor, made some very efficient ones. Slider is also heavily into them at the moment, and I was about to build one as well when Slider mentioned he was using the coils out of the little dancing flower toys. And this reminded me of something I bought my wife some 17 odd years ago, which is this little device here. You can see a couple of dolphins on the top, and it's just swinging away backwards and forwards. This thing has been running on the shelf for 17 years, minus 2 or 3 weeks when we shift house every now and then, but well over 16 years in total on the same battery. So now that the wife's taken off to work, we're going to have a little look-see at this wonderful little toy that's been running for more than 16 years on the same battery. I don't know what sort of circuit it's got inside of it. We are going to find that out, and hopefully we'll have it all back together before the wife gets home and back on the shelf. The battery is a 9-volt battery. Like I said, never been changed. Of course holds a lot more energy than a capacitor, but it's been running for a very long time on that one battery. Now I would have expected that the shelf life on the battery alone, just sitting on the shelf, would not be as long as 16 plus years. So what we're going to do is we're going to do a few tests on this. I've got a 2200 microfarad cap here, 24 volts. We're going to put 9 volts in that, see how long it runs on that. We'll also chuck the scope on it, although I'm not sure how the scope's going to go, because as you can see the cycles are probably 2 cycles every second, 2 to 4. So I'm not sure what the scope's going to show there, if anything at all, but we'll give it a try anyway. We'll chuck a CSR in line with the battery, have a look on the scope, and we can calculate some sort of power draw that the device is drawing from the battery. And the very last step will be, of course, to open it up and have a look to see what actual circuit is inside it. First we're going to do a bit of a run test on a capacitor and see how that goes, so we'll go and get set up for that. While we're at it, the first thing I want to show you was the voltage on the battery. It's got 9.4 volts. This is of course the original battery. Now I have noticed that the battery is starting to swell on both the sides, and it is not like a normal battery would be, where it is nice and flat. The sides are actually starting to swell. So it's still got 9.4 volts in it after 16 plus years of operation. So the old ever ready with the cat, they don't actually look like that anymore, but you probably can't see it, but the battery is starting to go round and the seams are starting to depart the bottom casing of the battery, but nonetheless it's still got 9.4 volts in it. So I thought I'd just chuck that in while we're at it, and we'll always know that that's the battery for it, because it is different to the ever ready you buy today, as in the pretty little pictures and decals on it. So anyway, let's get started with the capacitor test. We'll be back shortly. So the first thing we want to see here is if the motion of the device or the toy, the magnet passing over the coil, if it's been designed so as it can send charge back to the battery. Here I have our 2200 UF cap, which I've discharged. You can see a little bit of recovery voltage coming back in. We're at 59 millivolts and climbing slowly, but that is just the recovery voltage of the cap. So what I'm going to do is just give it a little swing and see if we can put energy into the cap just by the motion of the magnet passing over the coil that is no doubt in there. So we'll see if the circuit's designed to put back into the battery some of that which it took out. Of course we know it's not going to put it all back in there, but we'll see if it actually does charge that cap, which means it will actually be sending some power back to this battery. So we'll give it a swing. As you can see, the voltage is climbing quite nicely in the cap. We're now at 0.3 of a volt and still climbing. At this point we're sort of staying around the same voltage in the cap. As you can see now it's starting to drop. The motion's getting smaller, there's less energy in the cap. So less energy going to the coil, less push on the magnet. But as you can see from that, it does indeed send power back into our capacitor. We can also see from that that the power drain is quite small. So the circuit is definitely designed so it can send power back into the capacitor. It would be nice if that stayed right where it was, that voltage in the cap, and it continued to run. It is doing quite a good job. So okay, so we know the circuit includes the ability to send energy back to the capacitor, so it will be sending energy back to our battery. That'll be the energy which it does not consume, that is left after the process of the coil firing up, pushing the magnet. Cool stuff. So now we're going to try and set it up and have a look at the scope across the battery and a current sensing resistor, or a current viewing resistor. So we'll go ahead and get that sorted out and we'll come back. Okay, so I've got our scope across our CSR, and I'm just using a 100 ohm resistor for that CSR, and as I expected we're not getting much of a picture on the scope because the cycles are so slow. So I'm going to try and capture a frame. On the run stop. Oh, missed it. This is tricky. Oh, there we go. managed to get that one. I don't think I can. Oh, yes, I can. Okay, so after all that, there's our waveform. Let me zoom in there a little bit for you. Now the thing with that is I can't see any reverse current across that resistor, so I'm not sure how it was charging up the cap. It doesn't seem to indicate any current flowing in the opposite direction. So pretty eventfully unexciting, that little test, but it does seem we are missing our charge going back into our battery, although we do have voltage across our current sensing resistor. It then drops off to 0 and fires back up shortly afterwards. So I don't know where the reverse charge has gone. It should be a negative voltage showing across that resistor indicating a reversing current flow, but it's not there. So I'm not really sure why it is not there. Now what? Well, let's pull it apart and have a look inside and see what's going on inside the system and what kind of system it is. Okay, so now that we've disassembled it, we have some answers to questions. Here we have a transistor and of course a bifilar wound coil. Nothing more. This is the cool jewel circuit with the two coils wound together on one former instead of being separate. Nothing more. Two coils and a transistor and a battery. That's it. So it's also basically the Bedini circuit minus the resistors and variable resistors and diodes and all the other rubbish that's in them. This is the cool jewel circuit, plain and simple, with the two coils of wire wrapped around the same core. Nothing more. So that explains as to why we can't get a decent voltage back into the battery, or any current flowing back into the battery, and it clearly explains the operation of the system. So nothing out of the ordinary or new or fantastic in here, and I suspect that the efficiency is purely due to the resistance across the drive coil, which is 167.3 ohms. So or 163.7, one of the two, quite high, and that's all there is to it. Nothing special at all. Alright, so yeah, we're going to go and put this back together before the wifey gets home. Been a fun experiment, but wasn't really anything out of the ordinary to be found with this little setup. Quite simple. Okay, so we're trying our best here out in the sun to get an eyes on of the numbers on the transistor. Probably making you seasick because I can't stand still. But that's it. The resistance on the coil is 165.7 ohms. Oh, there we go. See if I can steady myself a bit somehow. Anyway, I need to tell you, if my wife could see me at the moment and what I've done to her little gift, I think she'd tear me a new bottom. So I'm going to go and put this back together now before she gets home from work. Okay, so I've got it all back together. It still works. I've got no screws left over, Slider, and I've even left the dust on it, so it doesn't look like it's been touched. So there you go, up and running. I think we're safe. We'll get it back on the shelf before the boss gets home and starts asking questions. Cheers guys.